Hello, this podcast is going to be a review of stuff that you learned in chemistry. And we're learning that matter consists of elements and compounds, which in turn are made up of atoms, ions, or molecules. What is matter? Well, matter is anything that takes up space and has mass. Basic building block of matter is the atom, and the Bohr model of the atom is pictured and the atom is the smallest unit of matter into which an element can be divided and still maintain its properties. So you could take, say, a chunk of carbon and chop them to smaller and smaller pieces, and it still is carbon until you get down to the individual carbon atoms, which is what you have pictured here. And that carbon atom consists of 6 electrons and 6 protons and 6 neutrons. If you take a piece of carbon and you chop it up into smaller and smaller pieces, you're going to still have carbon. The properties of carbon are going to be there. Eventually you'll end up with an individual carbon atom, which is what you have pictured here. If you chop it up any finer, you'll be breaking apart the carbon atom, and the properties will be different, and you won't end up with carbon anymore. And what you see in the diagram here are the subatomic particles that make up the atom. There are 3 basic subatomic particles. There are electrons, which have a negative charge, and protons, which have a positive charge, and neutrons, which are neutral. The protons determine what the element is, and that's by the number of protons. If there are 6 protons, then it's carbon. If you add 1 proton, then you'll end up with 7 protons, which is nitrogen. If you take away 1 proton, you have 5 protons, which is boron. Both of them have completely different properties than carbon. Adding and take away electrons, you'll have different properties, but it still will be carbon, and that actually is involved in chemical reactions. Neutrons, you'll end up with different isotopes, and their other properties are involved in, say, radioactivity, like what you have here with carbon 6 and with 6 protons, 6 neutrons. This is carbon 12, which is a stable atom of carbon. If you add 1 neutron, then we'll end up with add 2 neutrons, you'll have carbon 14, which is radioactive and is used in radioactive dating. Now, for elements, an element is a fundamental substance that has a unique set of properties and cannot be broken down by chemical means. And elements are pure substances. They're made of only one kind of atom, and element and atoms are frequently used interchangeably. And over here we have a table that shows the elements that are important to environmental science. The first several on the list are the ones that are important to life, particularly hydrogen, carbon, oxygen, and nitrogen are the ones that are very important to life. And I guess phosphorus too, and I guess sulfur. And we'll be looking at, and also in this unit, we're going to be looking at several of these elements cycling. Other ones like uranium, we'll be looking at that in terms of nuclear power. A compound is a combination of 2 or more atoms held in fixed proportion. Properties of compounds are different from the properties of their atoms. And over here we have compounds that are important in environmental science. Let's look at let's look for example at sodium chloride, the first one here. Sodium, Na, pure sodium is a metal, and it's a highly reactive metal. If you take that metal and you put it into water, it will explode. Chlorine is a poisonous gas. Put the two together, sodium chloride, it's table salt. Use it, and we frequently eat it. So we have 2 things that would be deadly to us, put it together, and it's something that's commonly found in our food. So the properties of the compound are very different from their component atoms, and they're in fixed proportion. The compound has equal proportions of 1:1 of sodium to chloride, equal amounts of sodium, equal amounts of chlorine. And then we come to ions. An ion is an atom or a group of atoms with an unequal number of electrons and protons. And what happens is that these ions form by atoms gaining or losing electrons. Those that lose electrons become positive ions. Those that gain electrons become negative ions. Number of protons don't change. That's a nuclear change, not a chemical change. It's just that the electrons change. So a hydrogen ion is one that's lost an electron, and a chloride ion is one that's gained an electron. And this table here shows the ions that are important in environmental science. And acidity is something that's important in environmental science too. And acidity measures the amount of the hydrogen ion in water usually. pH is what measures the thing which measures acidity. And pure water has a pH of 7, and that's neutral. And as the pH goes down from 7, you go down as far as 1, the acidity increases. And when you go from 7 and go up to as high as 14, then the water becomes more and more basic. And what you have over here in this picture shows the pH, shows what happens with the pH paper that we're going to be using. Is we have universal pH paper. You take that paper and you put it in a solution, and it will change color. That color will show you what the pH is. So I'm going to show you a video now of testing the pH of aquarium water. pH is very important in environmental science, particularly in aquatic environments. And it's very important also if you have a freshwater aquarium or a saltwater aquarium for that matter. And those of you last year who saw remember last year I had an aquarium, and when I brought the fish home, a lot of them died because there's a pH problem. Only one of them survived, this one right here. And the other ones have added. And one of the problems with it was that I wasn't too careful with the pH, but I am now. And I'm going to show you how to check the pH. First, I have to take out a sample of the water. And then I put in the pH solution. Just 3 drops to do. And mix. Now these are the colors that it could be. And if it's on this range over here, that means acidic, which is bad. If it's more in the bluish range, which is what it was when my fish died, that's also bad. You want it neutral, which is 7, which is good. And put this in here, I see now the pH actually has gone down a bit. So it's actually more in the basic range. So what I have to do is I have to bring the pH down a bit. So I have to add some acid to this. So I have this thing here called pH down. And I'm turn the filter back on so that it'll mix it. I turn the filter off so that the noise doesn't interfere with the podcast. And I'll check it in a little bit later once the acid is mixed to make sure that it's back to 7, which actually it was a few days ago. Now we come to chemical formula, and chemical formulas show the number and types of atoms in a compound. And every element has a symbol with 1 or 2 letters. The first letter is capitalized, and the second letter is lowercase if there is a second lowercase letter. And like an element for hydrogen is just capital H. There's only 1 letter. But for sodium, it's Na, capital N, lowercase a. So it's 2 letters, first capitalized, second is lowercase. If there's a number before the compound, that tells you how many of that compound there are. If there's no number, that means there's only 1 of that compound. So what you see over here, 2CO, that means there's 2 molecules of CO. CO is carbon monoxide, by the way. If there's a subscript, that's where you see subscript means that the number is small and underneath the letter. That means that there are that many atoms of that atom. And if there's no subscript, that means that there is only 1 of those. So in H2O, which is water, that means there are 2 atoms of H because the H has the 2 subscripted, and only 1 atom of O of oxygen because there's no subscript underneath the O. For organic and inorganic compounds, this is a review of what we learned in biology and also chemistry. Organic compounds are compounds that contain both hydrogen, which is H, and carbon, which is C. All other compounds are inorganic. Ones which have only C, like carbon dioxide, are inorganic because they have carbon but not hydrogen. Water has hydrogen but no carbon, so that's inorganic too. There are 4 types of organic compounds that are critical to life: carbohydrates, lipids, proteins, and nucleic acids. Now we come to our concluding questions. What is the difference between an element and a compound? What is the difference between an atom and an ion? What is the pH of pure water? And how many Na atoms or sodium atoms are in NaCl? That concludes the podcast, and I'll see you in class tomorrow.